Now we will study what do you mean by that speed and velocity. So you might be going on your two-wheeler and there is one indicator that we will show you the speed, so that we are calling it as a speedometer or that odometer. So generally it defines your speed, but it doesn't tell you in which direction you're going. So that definitely speed will give you only the magnitude. It is not going you to the direction. So that we will just see about that your speed and velocity. So again, I will say that. So then what do you mean by that speed? So simple, we will say that speed is nothing but the distance upon time, that we know basic thing, that is your about the speed. But only the thing is that it is having only the magnitude. The speed is having only the magnitude. It might be 100 km per hour, 200 km per hour. Yeah, so that is your speed. Then again, if we just talk about, obviously the distance is also a scalar quantity. The time is also scalar. So the speed is also your scalar quantity. So that is what we can say for this. Yeah, speed. So that is a scalar quantity which is having only the magnitude. So the next thing, then definitely what is difference in that velocity? So the velocity is having magnitude as well as direction. So that is what we will say, the velocity is equals to displacement upon time, and we will show the displacement. So with respect to that position vector, so this is O, let's say this is the position P. So let's say you can say that. So this is the position vector that is given by that displacement. So you might see that. So this displacement, which is nothing but your OP bar upon time. So it is having the magnitude as well as direction. So you are just standing over here and the complete description for you. So I will say that. So you are running in the east direction. You are running in the east direction, let's say for example, with a speed of 10 meter per second. So that is what we can say for the velocity. So it is having that magnitude as well as direction. So this is about your velocity. Then coming to the next point. So this is what we can say for the velocity. Obviously again, that velocity, we will say that it is a vector quantity. So this is again a vector quantity which is having magnitude as well as direction. There are various types of your speed or velocity. It might be uniform, then it might be non-uniform. Then what is the average? What is the instantaneous? So first we will see that. What do you mean by that? Uniform speed or velocity. So now what do you mean by uniform? So definitely you have to keep your momentum. So that means if you're getting, suppose let's say for example 90% in the 8th standard, then throughout up to the 12th, if you're getting the 90%, that means you're uniform. Your performance is uniform throughout your that 8 to 12 standard. So that is what we will say that. Now from this point of view, so we will say that it is a uniform speed, means the object is going to cover. Yeah, so the object is going to cover. So initially it is at A, then it reached to the point B, then again it has covered the distance of 5 meter in 5 seconds. Again in the next 5 seconds, he further covered the distance of 5 meter. Again in the next 5 seconds, again he covered the distance of 5 meter. So we will say that the object is going to cover the equal distance in equal interval of time. So that is your uniform speed. The same thing we will say for your uniform velocity also. If the object covers equal displacement in equal interval of time, that is nothing but your uniform velocity. So that means simple. If the object covers equal distance, let's say here it is 5 meter in 5 seconds throughout its journey. So that is a uniform speed. When you're going on that highway, so definitely your speed is uniform. It is not going to change. But suddenly when you stuck into the traffic, so definitely your speed is going to decrease, and that you can say some things, that is a non-uniform. So the next thing, obviously the non-uniform speed and velocity, where I will say that the object is not going to cover the same distance, yeah, in equal interval of time. So let's say in the first 5 seconds, it might be covered. So let's say that is nothing but 50 meter in the first 5 seconds. In the next 5 seconds, it might be covered just only 10 meter. So likewise, the distance covered by him, now it gets vary. It gets vary. It is not constant. So which is nothing but what we will say that it is a non-uniform speed or velocity. Again, what do you mean by that average speed or average velocity? The same that almost. So average means obviously we have to see that the average speed is your total displacement. Yeah, so this is what we can say. This is the uniform speed. So uniform speed where we will just say that the object travels the equal distance. Yeah, I just told you that if the object travels equal distance in equal interval of time, so that is nothing but your uniform speed or velocity. Then we just discuss about the non-uniform. Obviously it is going to travel unequal that distance or displacement in equal interval of time. That is, you can say that it is a non-uniform speed or velocity. The third thing also we have just discussed. Yeah, now what do you mean by that average speed? So you have to take the average of your entire journey. So that means simple. So the total distance or displacement during your entire journey upon your total time taken. So that is how we can just find the average of that your speed or average velocity. Likewise, previously used to give the exams throughout the year and final result based on the average of your all the marks throughout your, you can say, semester or throughout your year. So simply we are just taking that average. So the same thing, the average speed or velocity, that is your total distance or total displacement traveled upon the total time taken. The formula again the same thing, that is a distance or displacement, that is a delta x, and time is delta t. So which will give you the value of your that average speed or average velocity. Again, what do you mean by now instantaneous speed or velocity? So the instantaneous speed or velocity means the velocity at a particular instant or time. So you left on the bike from your home and you just travel certain distance, 100 meter, and you reach into the market. So definitely your velocity is going to change. So what is the velocity when just you reach in the marketplace? What is the velocity at a particular instant of time? So that is nothing but your instantaneous speed or velocity. The velocity or speed at a particular instant. Yeah, so that is nothing but we will call it as a instantaneous speed at that particular instant. Average means we are taking the average of your complete entire journey. But instantaneous means I have to just find the speed or velocity at that particular instant. So that is what we will call it as an instantaneous speed or instantaneous velocity. Again, the same velocity is equals to displacement upon time. So just to make sure that limit delta tends to 0, delta t tends to 0, means your time interval should be very small. So just to make sure that, you just get a very accurate result. So definitely if they're asking you, what is the velocity at t is equals to 5 seconds? What is the velocity at t is equals to 5 seconds? So how you will do it? So definitely this is t is equals to 3. Yeah, and this is, let's say again, t is equals to, for example, let's say this is again 7, and you have to just find the velocity at t is equals to 5. So I will just take more smaller interval for that. I will just consider, so if I'm saying that if you want to find the time that is t is equals to 5 seconds, you have to find the velocity at t is equals to 5. I will just find the time interval. So this is t is equals to 5. So let's take t is equals to 4.9. And on this side, take t is equals to 5.1. So this del t, you have to make it a very small one. So corresponding to that, just take the difference between that your x position. Then you will get a very accurate result from that graph. You will get a very accurate result by just, you can say that, making that interval a very small one. So just selecting a very nearer value. So you will get the approximate or the more correct value when you just make that interval very less. So that is what we can say for that your instantaneous speed, or that is the instantaneous velocity for that your object.